Hello and welcome to the spring series of the Inflation Drivers and Dynamics webinar sponsored by SEBRA and the Federal Reserve Bank of Cleveland Inflation Center. This is the second of 5 seminars that I've organized with Raphael Schunle of Brandeis University. And today's session will be moderated by Rob Rich at the Center for Inflation Research at the Federal Reserve Bank of Cleveland. And I'll hand the mic over to him to introduce the speakers.
Thank you, Dominic. Good morning, afternoon, or evening, depending upon where you are. Thank you for joining the webinar. The topics of today's sessions are lifetime memories of inflation, evidence from surveys in the lab, and living up to expectations, central bank credibility, and the effectiveness of forward guidance and inflation dynamics post-global financial crisis. I want to express my special thanks to the organizers, Raphael Schunle, Brandeis University and SEBRA, and Dominic Smith from the U.S. Bureau of Labor Statistics. So a little bit of background information for today's webinar. The webinar is 45 minutes in total with 2 presentations of approximately 15 minutes each and 10 to 15 minutes of Q&A at the end. Attendees do not have the option to switch on their audio video, but are invited to write comments or questions in the Q&A space. Attendees can, of course, post their questions during a presentation, so you do not need to wait until the end to do so. I will then select questions to be answered in the Q&A portion of the webinar after the presentations. The webinar is also live streamed via the SEBRA YouTube channel and is also recorded and made available on the SEBRA website and SEBRA YouTube channel after the event. And as a disclaimer, participation in a SEBRA webinar does not constitute or imply an endorsement, recommendation, or favoring endorsement of the views, opinions, products, or services of the Central Bank Research Association or any other participating institution, individual, or entity. All views expressed during a SEBRA or SEBRA co-hosted event are strictly those of the authors, discussants, and other participants, and not those of SEBRA, the co-sponsoring institutions, or any other participating institution. So with all of that as background, I would like to introduce today's speakers. Our first speaker is Yuri Gornichenko, QuantEdge Presidential Professor of Economics at the University of California, Berkeley. He'll be speaking on lifetime memories of inflation, evidence from surveys in the lab. Our second speaker is Stephen Cole, Associate Professor of Economics at Marquette University. He'll be presenting Living Up to Expectations, Central Bank Credibility, the Effectiveness of Forward Guidance, and Inflation Dynamics Post-Global Financial Crisis. So with that, I'll turn it over to Yuri, and Yuri, the floor is yours.
Thank you so much, Rob, and thank you very much for having me in this series. It's a great pleasure to be here. The paper I'm going to present today is joint work with Isabel and Olivia. And, in this paper, we try to shed more light on how memories shape expectations. We know from prior work that big events like hyperinflations, depressions, wars have a profound effect on how people think about the world, how they think about the future, and also how they act on these expectations. Incidentally, I lived through hyperinflation in Ukraine in the early 90s, a big depression there in the early 90s, and now the Russian invasion. So I have, checked all the boxes here. But, the objective of this talk is going to be not such a catastrophe. It's going to be a more mundane sort of event. We just lived through, double-digit inflation in many countries, and a key question for policymakers and for researchers, I guess, is whether this episode is going to somehow anchor inflation expectations for years to come, if it has some effect on how people think about macroeconomic dynamics and so on. Now, to answer this kind of question, we have to face a number of identification challenges, because when we have these big events, obviously so many other things are happening at the same time. And so it's very hard to isolate whether this, specific thing, like, 10% inflation is having a causal effect on inflation expectations. That's a big challenge. And what we try to do is to create, sort of simulate memories, experiences for households, and see if the simulated memories are going to affect somehow their inflation expectations. Now, to this end, we're going to run a randomized control trial in the Netherlands, and we're going to use a big survey of households in the Netherlands, about 10,000 people. And in parallel, we're going to do the same experiment in a lab setting. It's going to be a much smaller sample size, but there are some advantages of using lab experiments. Like you have these people for a longer period of time, you have a better controlled environment, you can ask more questions, this kind of sense. And the structure of this experiment is going to be very simple. First, we elicit the priors that people have about future inflation. Then we ask them to play certain games that kind of take them through, historical episodes of inflation. So it's as if we plant some memories in their heads. And then we measure their expectations again immediately after the game and a little later, 6 months later, to see if these games have a persistent effect on what they think about future inflation. Now, in the interest of time, I'm not going to give you every detail here, but this is roughly the outline of our exercise. And, maybe when you have a recording, you can spend some time reading the slide in detail. But, one thing I want to emphasize here is that we do the same experiment in the lab and in the survey. And that's important because usually these two settings are sort of evolving in parallel. The literature using labs is sort of not really talking to the literature using surveys and the other way around too. And so what we try to do is to bridge this gap between this, different approaches to measure expectations and how various, experiences can and memories can shape expectations of economic agents. Now, the first step, as I said, is going to be measure memories. And we do this through a series of very simple questions. For example, the first question would be something like, over your entire life experience, can you recall an episode of substantial increase in inflation? Then we'll ask a series of questions, when this happened, how big the increase was what was the initial rate of inflation, how it affected you, what was the duration of this, how confident you are in your responses, and so on. And, what is striking in this exercise is that we know when people were born, and we know what they presumably should have experienced as adults. And when we compare what people recall with their actual experience, objective experience, we see there are quite significant differences. For example, here we plot the distribution of answers to questions about when when you recalled high inflation experience happened. And you see lots of people here remember that inflation was, fairly recent. Some people here remember inflation in the 70s and 80s. Some people remember the spike in inflation just before the Great Recession and the global financial crisis. And so it's clear that, people kind of forget what was happening in the earlier years. Obviously, some of this is coming from age. If you ask older people when inflation happened, they're going to remember the 70s and 80s and also the recent episode. But even those, older respondents, they tend to remember more what happened relatively recently rather than what was happening in the 70s. So again, this is just to tell you that there is a difference between memories and sort of objective experience that people should have remembered. Now, what kind of words people use to describe their experience? This is a word cloud. You see, typically inflation is associated with, bad states of the world, a war, recession, corona, crisis, this kind of sense. And so in this sense, it's not unusual that we find something like this because other studies also document that inflation is associated with bad states of the world. Now, what we will do next is to compare responses in the survey and in the lab. And here we're going to constrain the sample in the survey to respondents who are roughly similar to respondents we have in the lab. Remember, in the lab, it's typically undergraduate students. It's going to be the University of Amsterdam. And when you ask, relatively young people, relatively educated people in the survey to report their inflation expectations and then compare their responses to the responses in the lab, you see a lot of similarity, right? So similar distribution, similar means, a lot of dispersion. So in this sense, it's good because it's telling us that, whatever we get from the labs is similar to what you get in the field where you don't have, students, you have a more general population. Now, having said this, you ask them other questions. For example, you ask them to report subjective probability distributions for inflation. And for example, look at the implied mean or implied uncertainty. And there you start to see differences. For example, in the lab setting, people tend to have an average higher implied means. They also have more uncertainty. And this is probably reflecting the fact that these people are much more financially literate. They're more comfortable with numbers. So numerical literacy is high and so on. So that we have some differences between the lab and the surveys, and we should keep this in mind. Now, what we do next is to see if memories are able to predict some variation in the cross-sectional distribution of inflation expectations. So, for example, in this particular column, what we have in this regression as a dependent variable is an inflation forecast for the next year. And then on the right-hand side, we have a number of respondent characteristics like gender, education, income, and so on. And then we add this extra variables here, which are going to be the recollections that those people have about inflation. And what is clear here is that above and beyond kind of the standard regressors that we use in this kind of analysis, we see that memories actually have a lot of predictive power. People who live through multiple episodes of high inflation on average tend to have higher inflation expectations. People who remember these inflations tend to have lower inflation expectations. There is also some effect from the intensive margin of how much inflation they remember. And the reason why it's important is because all of the things are significant on the top of what people think is inflation recently. This is the last variable here. And also kind of a summary statistic of what they experienced as adults in their lifetimes, right? So basically, this is a weighted average of inflation, where weights are going to be sort of declining in age. And here we don't invent anything, we just use the method proposed by Mel-Mindier and Nagel, right? So this is the objective that people have seen, objective reality that people have seen. This is what they remember. And so this regression is telling us that these memories have predictive power above and beyond the sort of objective experiences that these people have. Now, this is point prediction, so you can also look at uncertainty. Here, it's a little bit more mixed, but you still find some evidence that memories can affect how much uncertainty people have in their inflation forecasts. Now, none of this results is obviously causal, so we don't know, why these coefficients are significant and if they have sort of a structural interpretation, causal interpretation. And this is why we need to run an experiment where we create this or plant these memories in people's heads and see how these planted memories affect their behavior. Now, how do we do this? Well, we're going to ask people to play a game. We're going to show them 5 years of actual inflation. We're going to tell them which year that was. And then we're going to ask them to make a forecast for year 6. And when they submit their response, their forecast for year 6, we're going to tell them the actual rate of inflation in that year. Then we're going to ask them to make a forecast for year 7. And once they submit their response, we're going to tell them what was the actual rate of inflation in that year. And we keep doing this for another 10 years, right? So they have to practice their forecasting skills, so to say, for 10 years. And once they complete this game, we tell them, what episode that was. And we ask them again to make their inflation forecast for 2024, 2025, and the longer run. Now, what is going to be different across treatment arms in this experiment is what kind of episodes we ask people to face, right? And in the survey, we're going to see 3 treatment arms. A randomly chosen group of households is going to be assigned to this episode when inflation is going to be rising, right? So you're shown 5 years of data, and then you have to predict that inflation is rising. Another group of people is going to be facing the episode here in the 80s when inflation is consistently falling, and the final treatment arm is going to have to face, and predict inflation in this episode here when inflation is relatively stable. So we're going to call this up treatment, down treatment, and flat treatment. In the lab, because we have those people for a longer period of time, we can ask them to play the whole experience of inflation in the Netherlands since the 1960s. And the reason why you can do this only in the lab is because it's really a long game, and people have to be compensated to stay kind of connected and engaged in this game for a long time. We also ask people to play a game where inflation is on average 2%, and it varies between 1 and 3% range. So kind of really stable inflation environment, and see what happens with their inflation expectations after this. Now, once we play this game, we're going to look at the treatment effect of this game, so their posterior beliefs, and we're going to use a very simple regression where on the right-hand side you have their priors, dummy variables for each treatment arm, and then the interaction of the priors and the dummy variables, and these betas should be between -1 and 0 if these people are somehow Bayesian learners. Now, this is what we find when we do these games, right? So this is the prior on the horizontal axis. It's the posterior on the vertical axis. This black line here, this is the control group. It should be close to 45-degree line, and it is reasonably close to the 45-degree line. And then you can see what the treatments do to the distribution of inflation expectations. For example, when you treat people with inflation going up consistently over 10 years, you raise on average their inflation expectations. You see this intercept here is going to be somewhere here at a high number. When you treat people with down inflation or flat inflation, you see that this distribution is shifted down, and you also see a rotation in the distribution of the relationship between the posteriors and the priors, right? So you take these people with high initial priors and you move them down towards the signal you provide in the treatments. So this is to tell you that these games have an effect on their inflation expectations. Now, this is the survey. You see something similar in the lab. The results are going to be a little noisier, but this is mainly coming from the fact that the sample size is much smaller, right? So here we have 10,000 people. Here we have about 500 people. So results are a little noisier, but qualitatively, it's very similar. What is also interesting in this lab setting is that when you ask people to play the lifetime game, right? So you go from the 60s to the present. So presumably they face a lot more data, but it doesn't seem like the marginal effect of this extra long game is bigger than what you would get if you just present people with one disinflation episode. Okay, so it's an interesting observation. When you look at uncertainty, we have some statistically significant effects of these treatments, but the economic magnitude of this effect is going to be very small, very small. So it seems like we are moving the point predictions really, but not really the amount of uncertainty. Now, so this is telling us that we create this experience, the simulated memory, if you will, for people, and the simulated memories immediately affect the beliefs that these people have about future inflation. Now, the key question is whether these games that we ask people to play, the simulated experience, if this thing can have a persistent effect on their beliefs. And this is what we try to do next. We'll look at the long-run effects of these treatments. Now, what is here in the column 1? Okay, so column 1, this is the first wave. This is inflation expectations measured before the treatment. And this is the set of regressors I described before to you, right? So this is just to say that these memories have an effect. They predict the cross-sectional distribution of inflation expectations. Now, what we do next, we go to the second wave, which is going to be done 6 months later after the first wave. So it's a fairly significant period of time. And here again, the dependent variable is going to be inflation expectations, but measured 6 months later, while the regressors are going to be exactly the same thing we had here from the first wave, right? So the regressors here are going to be exactly equal to the regressors here. And the sample size is going to be smaller because we have attrition in the sample and so on, but qualitatively, the results are very similar. Even quantitatively, they're very similar, right? So you compare this to coefficients, and it's telling us that, the memories people have about disinflations or inflations, they continue to shape inflation expectations of these people. Now, what we do next is to extend the list of regressors and include treatment dummies, right? So if somebody was playing a game where inflation was flat, or inflation was rising, or inflation was decreasing, and we want to see if this experiences, the simulated memories, if you will, have an effect above and beyond what people experience historically, right? So these variables here. And we see that these coefficients are significant and quite large, which is telling us that even though, people, some of these people did not live through the 70s or the 80s, or even some people didn't really have an experience of inflation in 2000s, these effects appear to have an effect on their beliefs. Now, to conclude, do we see that this inflation or inflation memories have a causal effect? Through this power of the RCT, or randomized controlled trial, we see that there is a likely causal effect there, right? So these games appear to shape expectations of people. We also have sort of a methodological contribution here where we merge two literatures, the experimental macroeconomics and the survey literature. As I said, this literature is evolved in parallel, and we show that there are some sense we can learn from each other, so to say. We can have a bridge, a marriage between these different literatures, and use, weaknesses and strengths of this to learn something new. For example, surveys, you have a representative population, but you have relatively little time with the respondents. While experimental economics, you have a lot more control over the setting, but then you have to struggle with, how representative these results are. If you can generalize your results from the lab to the general population. We also document here that subjective recollections, these memories, they seem to be, very important. They have predictive power above and beyond actual experiences that these people have, actual history. So ideally, when we think about what shapes inflation expectations, we should ask people to recall, these episodes of inflation or disinflation, and that's going to be helpful in explaining their inflation expectations. And obviously, we have some future work. One key question here is how people form these memories, why they remember some things and not others, why memories are selective, so to say. We don't have an answer for this, but hopefully future research can shed more light on this. Let me stop here and thank you.
Okay, that's great. Yuri, thanks so very much. Just as a reminder to the members of the audience, you can go ahead and submit questions during the presentations. You don't have to wait till the end. So please, if you have any questions, please go ahead, submit them in the Q&A space, and we'll get to them at the end of our presentations. So with that, I'll now turn over to our second speaker. Stephen, the floor is yours.
All right, thank you. You can see my slides, correct? Yes. All right. Well, thank you. Very interesting presentation from Yuri. Thank you. And this paper is joint with Enrique Martinez Garcia from the Federal Reserve Bank of Dallas and Eric Sims from Notre Dame. And since they have a central bank co-author, standard disclaimer applies. But since I'm from a private institution, I guess all the views expressed are reflective of the president, Marquette, and the board of trustees. All right, I'm going to just assume that since everyone's microphone's muted, like everyone's laughing at that, so it goes better in person. So what we do is first look at forward guidance or the communication about the future path of the policy rate. And it's been a central monetary policy rule around the world since the Great Recession in the US, Bank of England, Bundesbank, Bank of Japan, and elsewhere as well. It's shown to have, in the literature, shown to have many positive benefits. We're at the zero lower bounds, can help signal, the future policy path, the lower for longer policies, which can stimulate the economy. Away from the zero lower bound, can also provide transparency and clarification about the future path of policy, and then also mitigates costs at the zero lower bound. But it seems like the results depend on the country and possibly across time periods as well.
So Stephen, I'm sorry to interrupt. Just could you move a little closer to your mic, I think? Maybe
I'm
just
sorry.
a little bit. If you could do that, I appreciate it. Thank you.
Can you hear me better now? Okay, sorry about that. So the results of forward guidance, the effectiveness seems to depend on the time, on the country and the time period. So what we do in this paper is study effects of forward guidance across time and space or countries. We use a standard New Keynesian model with forward guidance shocks, which I'll quickly go over in a second. And the way we introduce sort of heterogeneity is in the expectations formation process. We have a fraction of agents given by the parameter tau, which form expectations, forecasts through full information rational expectations or FIRE. And then the remaining ones, they don't, not through FIRE, through another simple DAR model. And importantly, they don't internalize the forward guidance announcements. And so we use estimation, Bayesian estimation on 4 countries, US, UK, Germany, and Japan. And then we also do some other G7 countries and Spain, which probably I won't get to in this presentation, but I'll show you the main results for US, UK, Germany, and Japan. Our time period is from 1990 to 2022, quarter 3. And to help identify the forward guidance shocks, we use expectations data about future interest rates from this consensus economics database. And just a quick preview of the results. So what we find is that forward guidance, it is a powerful tool, but it does depend across, its effects do depend country and across time. So that estimate of that tau, the ones who form expectations either by FIRE or not, it ranges from about 0.23 to 0.47, with 1 being the highest. And US has the highest, about 0.47, with Japan 0.23. And we also look at a rolling estimation exercise, and we find that this estimate of tau for all countries starts somewhat high and then slowly decreases over time, and with some variation across countries. And then the very interesting part is we look at missing inflation episodes. So post-Great Financial Crisis, pre-COVID, there's low inflation, especially in the US, below its inflation target for majority of the periods. And we look at, okay, what happens if that tau had been set to 1, if everyone formed expectations, according to a standard model with FIRE. And we find that, okay, in this counterfactual, yeah, there would have been higher inflation during that time, post-Great Financial Crisis. And then also zero lower bound wouldn't have been as much of an issue during that time. And so this is actually in our paper when we first thought of the idea. This was before COVID, and then the recent inflation surge happened. So we did another counterfactual exercise recently, showing, okay, what would inflation do if tau was equal to 1 as well for these countries? And show that, yeah, it does seem it would have come down much quicker than observed. So quickly, the model, it's a standard New Keynesian model. We have an IS curve, and we have habit formation and consumption in the household sector. And then on the New Keynesian Phillips curve, we have sticky prices as well as price indexation. And these are pretty standard models, but the way we add forward guidance is in the monetary policy rule for the central bank, assuming that the monetary policy of the central bank, they set interest rates, IT nominal interest rates, according to lagged interest rates, as well as inflation, output. And then here we have an unanticipated monetary policy shock, the epsilon TMP. And then at the end, we added new shocks, or anticipated shocks. And these are announcements by the central bank in period T minus L that the interest rate will change L periods later or in period T. And then capital L is the length of the forward guidance horizon. So this is time contingent forward guidance that we're modeling. It's like the new shocks in Schmidt-Grohe and Uribe 2012. So that's how we add in expectations. Forward guidance. And now the heterogeneity part is in the aggregate expectations. So our expectations in our model, expectations of Y with the vector Y being output gap, inflation, and interest rates. I'm going to say it's a sum weighted sum of central bank expectations that fire, ET fire, and that's formed following full information rational expectations. And it does contain those forward guidance variables that I just talked about. And then assume that the other fraction of the economy, some private sector forecasting model without forward guidance. So we're going to assume they form expectations based off a standard VAR. And maybe also a little more broadly, we may be able to interpret this tau not just as just a fraction of those who have fire expectations, but maybe it could also include the fraction of those who believe these forward guidance statements by the central bank. So, for instance, if we think about central bank credibility as an alignment of the Fed's statements about the policy path and public's expectations. So this quote from Janet Yellen in 2006, market participants correctly anticipating the actions that the Fed will make in response to economic news and shocks. And maybe perhaps if this tau maybe can also be thought about as if private sector expectations align with central bank expectations. So if this tau is anything less than 1, then we do have this heterogeneous expectations about the future policy path, some forecast heterogeneity. Central bank cannot perfectly steer expectations to its preferred path. And there's always some fraction of agents that do not incorporate these forward guidance shocks. So just perhaps another way to view this tau in our model. So in our estimation, we have our 4 countries in the main estimation, US, UK, Germany, and Japan. Our time period 1990, quarter 3 to 2022, quarter 3. And then we have our contemporaneous variables, real GDP, inflation, and the CPI for each country, and the short-term interest rate, the 3-month rate for the interest rate. And then to help identify some forward guidance shocks, we have this database of consensus economics giving forecasts about expected interest rates. We have it 1, 2, 3, and up to 5 periods ahead. And then we also have expected output growth and inflation. So quickly, I'm going to show you the estimates of tau across countries. So here is our full sample estimation. So you see here that US, that tau can range from 0 to 1, and the US, UK, Germany, they seem pretty high, with the US being the highest. However, Japan has the lowest 1.23, and throughout this results, it seems like Japan is somewhat of the outlier relative to these other 3 countries. So next, we look at, okay, with this difference across countries, what does that do? Difference of estimates of tau across countries, what does that do to the effectiveness of forward guidance? So to understand that, we compute this rolling estimation exercise where we look at a subsample of 69 observations. Start 69 observations, start in the beginning, and then estimate everything, and then compute impulse response functions to a positive or a favorable forward guidance shock. And sum the estimates or cumulative estimates of inflation output over periods 0 through 5, so the anticipation period of forward guidance. And that's going to be our measure of effectiveness for each window of 69 observations. And then we move the window up 1 observation and then we do it again and compute this measure of effectiveness, this cumulative responses of inflation and output to a favorable forward guidance shock. We do that across a whole sample to kind of get a sense of what are the effects if tau varies across time. So here's our results. And so on the columns, we have the US, UK, Germany, and Japan. And then on the rows, we have output, the responses, the measure of effectiveness for output to forward guidance, inflation to forward guidance. And then here we have these estimates of tau across our sample. And just starting here, we have this estimates of tau. So on the last row, for the US, UK, and Germany, starts somewhat high. and then it kind of slowly decreases. And then UK and Germany, they also have this like kind of big drop towards the end. Maybe that's towards, when the Europe, when they're fighting inflation, very, very low during that time. That could be part of the reason. And then the responses, the effectivenesses of output inflation, they seem to mirror, what this tau is. So in the beginning, US, UK, somewhat Germany too, they, output, response to output, response to inflation, to forward guidance seems to be somewhat relatively higher. Then it declines, kind of similar, follows a similar path of tau. And then the same thing as for UK and Germany. And then again, Japan seems to be a little bit of the outlier, pretty low tau, a pretty low effectiveness of forward guidance on output and inflation. And that may be due to, during the late 90s, 2000s, Japan was dealing with a lot of low growth, low inflation, interest rates super low too. So that could be possibly another explanation for these results. And then we turn to our next exercise. So for much of the period since the Great Financial Crisis, but before COVID-19, so central banks have, for the most part, missed their inflation targets during this time period and also struggled with the zero lower bound. And so we ask, okay, do historical missing inflation episodes, do they stem from this forecast heterogeneity that we're modeling? So what if private sector expectations, what if they are perfectly aligned with those assumed in a conventional macroeconomic model with homogeneous and full information rational expectations agents? So what we do is we estimate the model, with tau, letting tau be whatever the data says. And then we put all the parameters at their posterior mean, except we set tau equal to 1. So if all agents had homogeneous as well as full information rational expectations, and then we simulate the model to see in this counterfactual exercise what dynamics of output, inflation, and interest rates would be. So here's the US. So this solid line is the observed data, and then the dashed line is this counterfactual exercise data that I just described. And just a couple things I want to highlight is the post-Great Financial Crisis. Here we have inflation at the very top row. Up until, about post-Great Financial Crisis, we have, looks like inflation, would have been higher under this counterfactual exercise for some of the periods. And more importantly, too, if you look at the very bottom row, the nominal interest rate, it looks like the zero lower bound wouldn't have been much of an issue post-Great Financial Crisis as well. And GDP growth seems to be maybe fluctuate a little more, but about the same. But the main takeaway seems that it would have generated somewhat more inflation, as well as zero lower bound wouldn't have been as much of a problem. Similar stories can be looked at for the UK and Germany. And I'm just going to show you the nominal interest rate. We're just going to talk about the nominal interest rate, short-term nominal interest rate here. Zero lower bound doesn't seem to be an issue for the UK. And inflation at the very top row would have been a little higher too as well. And similar story for Germany. We have the nominal interest rate, would it have been, the zero lower bound wouldn't have been as much of a problem as previously, or as what actually happened, in reality. And inflation, maybe not as positive as in the US, but with spurts of a little more inflation. And then Japan, a little bit more of an outlier. We seem to have zero bound, probably would have been a little more of an issue towards the early 2010s under a counterfactual exercise. And inflation probably still would have been an issue too, as it going below zero, counterfactual exercise. So
Stephen,
yeah,
sorry to interrupt you. We're running a little short on time. Can I ask you maybe to go ahead and maybe wrap up a little bit so we can answer some of the questions?
For sure. Yeah. So actually, this is the last slide, and then we looked at what happens under this counterfactual scenario. What would happen to inflation if on its counterfactual scenario, tau is equal to 1. And you see here, I'm just zooming in at the last part of our sample, inflation in the US, UK, and Germany, it would have been much quicker to decline under our counterfactual scenario, and Japan is an outlier still. So conclusions, we looked at the effect of forward guidance across time and space, time and countries, and it looks like forward guidance effect is much more better relative to Japan for US, UK, and Germany. And then also too, in these counterfactual scenarios, which we would have more inflation, at least in the US, zero low bound would have been an issue for US, UK, and Germany under our counterfactual scenario if agents had full information expectations and homogeneous expectations. Okay, and with that, I am done. Thank you.
All right, great, Stephen. Thank you very much. So we have time for a few questions. Again, for those in the audience, by all means, feel free to submit your questions in the Q&A, and we'll get to them. We're going to start off, Yuri, with a question for you. Do you know whether survey respondents immigrated to the Netherlands? Does that explain part of the reason people remember high inflation at times when inflation in the Netherlands actually wasn't very high?
Yes, we know if people were born in the Netherlands or if they came from another country. The general population has a relatively small fraction of immigrants. When you look at the student body, there you have a more diverse, distribution, and so some people remember literally hyperinflations from their use of something. We tend to exclude these people because we want to focus on people who are mostly, born and raised in the Netherlands.
Okay, great, thanks. Stephen, the next question is for you. It's a bit of a technical question, but the drop in the UK is really sudden, especially for a rolling window estimation. What does this look like for other European countries?
Yeah, so the other countries that we looked at in Europe were Italy, France, and Spain. And that drop in at least the estimated tau, it was, oops, sorry about that. I don't know why that happened. So Italy, France, and Spain, it was a similar drop in that estimated tau as long as with the effectiveness of output of inflation, forward guidance on output and inflation towards the end of the sample. And then we also looked at Canada as well. It's not actually as significant in Canada, but for the other European countries, it looks somewhat similar as well. I can show you that too, maybe later on email.
Okay, thanks. Yuri, another question for you. How do you interpret the result that the posterior for participants given a flat history are scored a quote lower than participants given the down history?
Right. So remember, the posteriors are going to be a native average of the priors and the signal. And what is important in the signal is going to be the average inflation during this episode. When inflation was rising, we had a big average. When inflation was falling, we also have a big average because you start from a high point and you go down to more or less 2%. And when you look at the flat, it was literally 2%, an average. So we just give them a lower signal, so to say, in the flat treatment. And so it is natural that the posteriors are going to be systematically lower relative to other treatments.
Okay, great. And we have time now for just one more question. And Yuri, this again is for you. Did you also have an open-ended question about what features of inflation experiences people were thinking about when making their forecast? Maybe there are some other subjectively perceived as important features of inflation that may matter, but were not explicitly captured.
It's a great suggestion. I wish we had that question. So maybe in the next experiment, we will ask people to say something along these lines.
Right. It's always the ex ante, ex post, right? Always that sort of difference there. All right. So we're running out of time here. So I wanna thank both of our speakers for a very interesting discussion. And then in closing, let me remind everyone that the next webinar will be on April 18th. And they'll feature Gillian Burnett from Smith College. She'll be talking about inflation, war bonds, and the rise of Republicans in the 1950s. And then Hugh Montag from the Bureau of Labor Statistics post-pandemic drivers of inflation. So again, for all of us, thank you so very much for joining, and we'll see you again in 2 weeks. Thank you.
Thank you.
Thank you.
Thank you. Bye, everyone.
Bye.